Hi guys, welcome to the video on the properties of trapezoids. So, we're going over how to apply the properties of trapezoids to find missing angles or sides. Trapezoids make up the shape of quite a few everyday objects like handbags or in bridge building. That's why we're learning this, and you'll know you're successful when you can find missing angles or sides in a trapezoid with at least 80% accuracy. So, what is a trapezoid? A trapezoid is a quadrilateral with exactly one pair of parallel sides. You can see it has two bases and two legs. In a trapezoid, these parallel sides are called the bases, so it doesn't matter which one you put it on, but they have to be the sides that are parallel. Not the legs, but the sides that are parallel. Each trapezoid has two separate pairs of base angles. So you've got the red base angles up here, and you've got the green base angles on the bottom. You can pause the video if you need to write anything down. The definition of consecutive angles is two angles that are next to each other are considered to be consecutive. Angles are next to each other when they are on the same side, the left or the right, as each other. So in this trapezoid here, angle 1 and angle 2 are consecutive angles, and so are 3 and 4, since both are on the left, 1 and 2, or the right, 3 and 4. However, 1 and 4 are not consecutive, nor are 2 and 3, because they cross the shape in order to be listed. So 1 and 4 is not consecutive, are not consecutive, and 2 and 3 are not consecutive either. If you need to write any of this down, you can pause the video. First property of all trapezoids, and if you need to write it down, you can pause the video. The consecutive angle pairs between bases of the trapezoid are supplementary. So it's the same diagram as the previous slide. Angle 1 and angle 2 added together equals 180, and angle 3 and angle 4 added together is equal to 180 as well. We're going to come back to this a ton in this section. Definition of isosceles trapezoids. An isosceles trapezoid is a trapezoid whose non-parallel sides, meaning the legs, are congruent to each other. So, while the bases are parallel still, the legs, the non-parallel sides, are also congruent. The first property of isosceles trapezoids is that all of the base angles of an isosceles trapezoid are congruent. So if they're on the same level, the two top base angles are congruent, and the two bottom base angles are congruent. And then it still applies that A plus C and D plus B, each one of those pairs, respectively, adds up to 180. So not only does A plus B, not only is our A and B congruent, but A plus C and B plus D are also supplementary. Second property of an isosceles trapezoid is that the diagonals, which we defined in class as the imaginary segments that go from corner to corner, those diagonals are congruent. So diagonal AD is congruent to diagonal BC. And that's it for the properties of trapezoids, guys. So now we're going to start using these properties in order to calculate measurements of trapezoids. So in this example here, it says find the measures of angles A, B, C using properties of trapezoids. So not only is this a regular trapezoid, but I know that it is an isosceles trapezoid. And it's isosceles because it has two legs that are marked. So it's an isosceles trapezoid because of this and this marking right there. So those two marks, meaning the legs are congruent, since this is the base up here and this is a base down here. Those are the two parallel sides. I can use all the properties that were listed here, each and every single one of them. The diagonals being congruent, I can use that the angles, the base angles are congruent, and I can use that the two angles add up to 180 that are supplementary. So I'm going to start by just knowing that if this is 55, C has to be 55 as well, because those angles are congruent. And then I can use the property that these two angles here are next to each other. They're consecutive angles, so 55 and A are consecutive. So 55 and A are consecutive. So they are supplementary, and I can't spell consecutive correctly. Consecutive. And because they are consecutive, I can say that they are supplementary, which means 55 plus A, angle A, has to equal 180. So just doing a little quick math here and taking away 55 from both sides, I can know for certain that A must be equal to 125 degrees. And if A is equal to 125 degrees, that means that B is also 125 degrees because it is a base angle as well. And the two top base angles are congruent to each other, just like the two bottom base angles are congruent to each other. Okay, find the value of x in the diagram below using properties of trapezoids. There are no markings on this trapezoid, so the only property that I know, so there's no markings. So no marks. So I only have the first property here. And the first property is the property that tells me that this angle, angle A, and angle D, because they're on the same side of the trapezoid like this, okay, they're both on the left side, these two angles are consecutive and they add up to 180. So angle A plus angle D equals 180 because it's half of the trapezoid. So like I can draw a little fictional line here. Half of the trapezoid means half of two of the angles out of the 360 have to equal 180 because half of 360 is 180. So A plus D, I can substitute expressions in for those. So 8x plus 34, and then I add 6x minus 22, and that equals 180. I'm going to go ahead and combine my like terms on the left side to get 14x. And then 34 take away 22 is positive 12, is 180. So then I'm going to subtract 12 from both sides to get 14x equals 168. So then if I divide both sides by 14, I get x is equal to 12. And then I'm going to take this a step further and plug these into the formulas, the expressions I have. So 6 times 12 is 72. Take away 22. When I substitute x in here, this gives me a 50-degree measurement here, which, knowing the basic properties, means that this one here has to be 130. But if I plug in a 12 here as well, I'll get 96 plus 34 is 130 degrees. So works out like it's supposed to. Okay, the measure of AC, which is a diagonal, is 25. BD is equal to 4x minus 11. Find the value of x. Okay, so the diagonals here, and I'm going to make the assumption this is an isosceles trapezoid. It should have been listed. There was a bit of a typo. But this is an isosceles trapezoid, which means the diagonals are congruent. That was one of my properties of an isosceles trapezoid. And if the diagonals are congruent, that means that I can make their expressions equal each other. So I know that AC has to be equal to BD. So I can write the expression for 25, excuse me, not 4, 25 in place of AC is equal to BD of 4x minus 11. So then if I add 11 to both sides, I get 36 equals 4x. So dividing by 4, x equals 9. So x equals 9 in this case. Okay, one of the things that I didn't explicitly mention, but is still true, is that in an isosceles, not triangle, trapezoid, excuse me, this should be a trapezoid. That is a typo. So in an isosceles trapezoid, the diagonals of the trapezoid create two isosceles triangles and two congruent scalene triangles. Take a look. I have PDA is an isosceles trapezoid, and TIR, or excuse me, TDR, and I marked the two isosceles trapezoids with eyes. So we've got an eye here and an eye in the top one, an eye in the bottom one. Those two triangles are not congruent to each other, but they're isosceles triangles, which is important. And then the two scalene triangles are, because you have two congruent sides, two more congruent sides, and three more congruent sides. So they're congruent through SSS. So that's an important sub-property. It doesn't need to go on your flow chart. Just something to keep in mind that when you go ahead and make the diagonals, there's all sorts of congruent triangles in there. Leads me to my last example problem. In this isosceles trapezoid, so I can go ahead and make my marks here, ABCD, AB is parallel to DC, and BCD measures 25, which is marked, while BCA here is marked as 35. What is the measure of DBC? So this measure right here. So one of the things that I know about this is that these two sides here, this and this, are an isosceles triangle. That was the corollary we just looked at. So if these two are the same, is an isosceles triangle, this is also 25 degrees, meaning this entire angle is 60 degrees. And then logically, we remember that the two angles here are supplementary, which means angle B has to equal 120. But I not asked for all of angle B, I'm asked for a portion of it. I am going to use the whole parallel thing and think back to Unit 2 with the alternate interior angles theorem to say this 25, if this is an interior thing, these are two parallel lines, that's a transversal, BD is a transversal, so this angle up here is 25 degrees. So if this is 25 and the angle up here is 25, 120 take away 25 gives me a measure of 95 degrees for angle DBC is 95 degrees. Okay guys, in summary, trapezoids are quadrilaterals that have exactly one pair of parallel sides, and they have one property that is special to all trapezoids. And then isosceles trapezoids have legs that are congruent, and then this creates some more special properties, namely that the base angles are congruent, and that the diagonals of those are also congruent. So please make sure that you get those properties down in your flowchart. Thanks for watching, guys, and I'll see you in the next video.